Right now, beneath the busiest streets on Earth, something extraordinary is happening with every footstep. Millions of people walk to work every day, and until recently, all of that energy was wasted. Engineers have now figured out how to capture that energy and turn footsteps into electricity. The technology is called kinetic energy harvesting, already deployed across 40 countries worldwide. The tiles beneath your feet are no longer passive concrete. They are live power generators. This is the story of the pavement that learned to power a city. Hit subscribe because the city beneath your feet is only just getting started. For most of human history, the pavement beneath our feet has been the most overlooked surface on Earth. We engineered it to be strong, to be durable, but never once to generate a single watt of power. But in 2006, a young engineering graduate in London asked a question nobody had seriously considered before. What if the energy of a footstep, instead of being lost as heat, could be captured and stored? That question became Pavegen, today the world's leading kinetic energy tile company deployed in 40 countries. But the physics behind it stretches back much further to a discovery made in the 19th century. In 1880, French physicists Pierre and Jacques Curie discovered that squeezing certain crystals produced a measurable electric charge. They called it the piezoelectric effect, and for over a century, it powered sensors and microphones only. Nobody imagined embedding it into the ground beneath millions of commuters until the early 2000s arrived. In 2008, East Japan Railway embedded piezoelectric tiles beneath the ticket gates of Tokyo's Yaosu Station for the first time. Thousands of commuters walked over them daily, and the tiles generated enough power to light a single bulb. It was a proof of concept, modest in output but historic in what it proved was possible. The energy from human movement was real, it was measurable, and with the right engineering, it was capturable. Pavegen took that lesson and rebuilt it from the ground up, switching from piezoelectrics to electromagnetic induction. Each new tile compresses 10 millimeters underfoot, spinning a miniature internal generator every single time someone takes a step. From a Victorian crystal experiment to a live power source beneath the world's busiest streets, the journey had begun. To understand why kinetic pavement matters, you first need to understand what happens beneath your feet when you walk. Every human footstep transfers between 70 and 100 kilograms of force directly into the ground beneath it. For centuries, that force simply disappeared, absorbed by concrete, converted to heat, and lost to the atmosphere forever. Inside a Pavegen tile, that force is intercepted. The surface compresses 10 millimeters and sets a flywheel in motion. That spinning flywheel drives copper coils past magnets, the same fundamental principle powering every generator on the planet. The result is 3 to 5 joules of clean electrical energy captured from a single human footstep. Individually, that sounds small, but in a transit hub processing 50,000 footsteps an hour, the numbers change fast. That energy is stored in onboard batteries inside each tile, ready to power whatever the city needs next. But Pavegen's engineers didn't stop at energy. They embedded wireless sensors directly into every single tile as well. Every tile now tracks footfall volume, pedestrian flow patterns, and dwell time, transmitting that data wirelessly in real time. Cities are no longer just harvesting energy from their streets, they are harvesting intelligence from them too. Each tile becomes a node, part sensor, part generator, part live data feed powering smarter urban decisions. Pavegen recently launched Solar Plus, a hybrid tile combining kinetic harvesting with solar cells for around-the-clock generation. The solar hybrid claims up to 30 times more energy output than the original tile in optimal outdoor conditions. In the summer of 2012, London was hosting the Olympics, and an experiment was quietly unfolding beneath the crowds. Pavegen had installed kinetic tiles at West Ham Tube Station, one of the busiest Olympic transit points in the city. Every surge of spectators heading to the games was unknowingly generating electricity with every single step they took. The energy powered LED lighting along the walkways, the first time a public crowd had lit its own path. It was a small installation, but the images of a crowd powering its own lights traveled around the world overnight. 3 years later, London's Bird Street became the world's first retail zone powered entirely by pedestrian foot traffic. Shoppers walking down Bird Street were powering the ambient sounds, the signage, and the lighting without ever knowing it. Across the Atlantic, Washington, D.C. installed Pavegen tiles near Dupont Circle to power pedestrian street lighting directly. These weren't experiments anymore. They were permanent installations in the most footfall-dense urban environments on Earth. For the people walking these streets, nothing had visibly changed, except that every step was now doing something meaningful. That invisible contribution, footstep by footstep, is what makes kinetic pavement unlike every other renewable energy source. Solar needs sun. Wind needs wind. Kinetic pavement needs only the one thing cities already have in infinite supply: people. By 2025, Pavegen tiles had been deployed across more than 40 countries, from airport terminals to marathon routes worldwide. At one Schneider Electric marathon, runners' kinetic energy powered the entire lighting installation along the race route directly. Every city on Earth already has the fuel, packed into its pavements, flowing through its streets, every single day. The question everyone asks about kinetic pavement is simple. Does it actually generate enough energy to matter at scale? The honest answer requires separating what the technology does today from what it is being engineered to do tomorrow. Today, a single Pavegen tile generates 3 to 5 joules of energy from every footstep that crosses it. Each joule is enough to power a small LED light for approximately 1 second, modest but measurable and real. At a busy transit hub processing 50,000 footsteps per hour, that adds up to 250,000 joules. That is enough to continuously power hundreds of LED streetlights, sensors, and mobile charging stations simultaneously. London's Bird Street installation demonstrated a 40% reduction in grid reliance for the retail zone it served. That figure, 40%, is not grid replacement, but it is meaningful, verified, and commercially significant. Pavegen's sensor layer adds a second dimension of value that pure energy output figures alone cannot capture. Every tile transmits anonymized pedestrian data, footfall counts, movement patterns, peak hours, directly to city management dashboards. That data helps cities redesign pedestrian infrastructure, reduce congestion, and allocate resources where foot traffic actually flows. The commercial case for kinetic pavement is therefore dual: energy savings plus urban intelligence in a single tile. Pavegen's Solar Plus tile pushes the energy equation further, claiming 30 times more output than the original kinetic tile alone. Combined solar and kinetic harvesting means energy generation continues around the clock, day and night, sun or cloud. The durability challenge has also been addressed. Third-generation tiles now use graphene-reinforced composites to survive harsh climates. Cost remains the honest barrier. Kinetic tiles currently run between $50 and $100 per square foot to install, but economies of scale are already driving that cost down, and hybrid solar integration is accelerating the business case fast. The data is not yet at grid scale, but it is real, it is verified, and it is growing every year. Let's be honest about what kinetic pavement is and what it is never going to be. It is not going to replace the national grid. That is not the technology's purpose. It never was. The real opportunity is something more surgical: small amounts of clean energy, produced exactly where it is needed most. Street lighting, pedestrian sensors, emergency signage, mobile charging. These are the loads kinetic pavement can serve right now. In cities where energy costs are climbing and infrastructure budgets are shrinking, that kind of local generation matters enormously. But the energy story is only half of what makes this technology genuinely transformative at an urban scale. The other half is the data, and the data layer is where the long-term story becomes commercially and politically significant. Every tile is a sensor, every footstep is a data point, every hour of foot traffic is a data set. Cities that know exactly where people walk and when can plan infrastructure with a precision never before possible. Smarter bus routes, better placed benches, redesigned crossings. Real decisions driven by real movement data, not historical assumptions. But the data layer also opens a question that urban planners and civil liberties advocates are beginning to confront seriously. Who owns the data your footsteps generate? You, the city, the manufacturer, or whoever pays the most? Pavegen states its sensor data is fully anonymized, but anonymization is only as strong as the systems enforcing it. As deployments scale into airports, transit hubs, and city centers, the volume of movement data grows exponentially fast. Smart city advocates say this data makes urban life genuinely better. Safer streets, less waste, lower emissions overall. Critics say it creates a surveillance infrastructure embedded so deep in the ground that most citizens never notice it. Both arguments are valid, and both deserve to be part of the public conversation before deployment scales further. There is also the equity question. Who gets kinetic pavement first, and whose streets stay plain passive concrete the longest? High footfall areas generate the most energy, which means the technology naturally benefits already prosperous urban centers first. Deploying kinetic pavement equitably will require deliberate policy mandates. Market forces alone will not get it there. Looking ahead, researchers are now exploring vehicle-integrated kinetic harvesting beneath highways and high-volume urban intersections worldwide. A single vehicle lane under constant traffic could generate orders of magnitude more energy than pedestrian footfall alone. The pavement beneath our feet is only the beginning. The real prize is the road beneath our wheels. Hybrid solar kinetic systems are already commercialized. The next generation of urban surfaces may harvest energy from multiple sources simultaneously. Every road, every pavement, every public square, each one a potential microgenerator quietly powering the city around it. The city of the future may not need a power station if every surface is already one. We began this story beneath the busiest streets on Earth, where millions of footsteps were disappearing into nothing every day. Today, those footsteps are generating electricity, powering streetlights, feeding data into city dashboards, and reshaping urban infrastructure. The pavement is no longer passive. It is alive. It is intelligent, and it is only just getting started beneath our feet. Every step you take from this moment forward is no longer just movement. It is potential energy waiting to be captured. The pavement just learned to think. Hit like, share this with someone, and subscribe to SynthCosmos. We cover the science reshaping our world as we know it every single week. We'll see you in the next one.